All right.
Can you see my screen?
Sure can.
All right, let's do this. Okay, so yeah, the title is Beyond Load Tests, Building Confidence through Performance Engineering. Like this is more like lessons learned from working on large scale cloud payment systems. And I'm Guy, I'm a software engineer, more on the development side, but I got very interested in the performance, and overall performance engineering was a big concern for me. So that's why I'm here. Yeah, so first thing, like I want to highlight, like we start with a new product, right? So we want to consider performance from the get-go, like designing with performance in mind. And I would say like it's like the first phase. Um, and as a context, like the product that we were building was like a large payment platform solution. We were enabling merchants to accept payments on their smartphone. And why I say platform is because it's not a single specific product like Square, let's say. Square could be one of the partners using the solution. So there could be hundreds of partners in many countries. It's just to give an idea of the size. And I'm thinking here like millions of merchants using the solution. There's a little diagram here. Like it's basically you can tap your credit card on the smartphone and it would talk with the cloud servers, and this is where is this space that I'll be focusing on is the server side. Like this is a set of like smartphone-facing web services and REST APIs. So basically, sitting on the servers, receiving the calls from all of these devices that wants to do the payment transactions. So it's a very high frequency flow. It is synchronous, so you need to give the response immediately back to the device and to be able to continue, right? And this is what we were going to build, and we wanted to build a system that can handle the potential load, right? So the merchant wants something that is smooth, it's reliable. It should not be slow and it should not be failing, because that means it's lost sales or frustration, right, for the merchant, and they might just switch to a different solution. So the goal is like fast, reliable APIs that just work, that's just not in the way of the merchant, right? Yeah, so designing that with the goal of performance in mind, right? Here I want to more like set the ground, like what are the main concepts we approach when you're designing for performance, like looking at also as high availability, resiliency, and scalability. So basically, in the cloud, we want to have multiple regions that can handle the traffic, so the devices are distributed and using this redundancy. And multiple replicas of the applications actually doing the business logic. And also there is some retry logics that would help with resilience. And like, for example, we have a device, which they call here a client. There is a region A or region B, completely separate, can be like in Eastern US or Western US. The device could connect to either of those and they are working. And there's a load balancer in the middle there. And the scalability is that once the device is actually in one of the regions, the region is basically a copy of the others. And inside that region, you could have an API gateway and the business services. And that could be the service X, service Y. And each of these services could have multiple replicas, right? Replica 1 and 2 and replicas. The device could connect to any of those. They are basically doing the same thing. They can be taken away, they can be put back, grow at any time. And then these services could be talking with a dependency that you may or may not control, and it might just be there, and you have that in the picture as well. And again, there's some load balancing here. There might be some retry logic for those calls coming in. Yeah. And then the performance engineer here that I see is that you'd come in and is this overall architecture reasonable for the expected scale, like the amount of traffic it would receive? What are the hardware resources to provisioning So this would be more the capacity engineer, like how would you make this work on the cloud? How many replicas? What is the CPU and memory to which proportion? And are the systems stateless so they can easily scale? This is the horizontal scaling that you can take one service and put another one and replace it without a problem. And what are the dependencies and how they affect the system because they might impact the performance. Yeah, so, and then to actually test and to see the behavior, I call it here the load, the one step we do is the modeling the load, right? We want to pretend to be the client. Like, and what would that look like? Like we would imagine like, what is the expected usage? Oh, we will have 100 merchants doing 10 transactions a day. And those merchant devices, they might come up to like 80 API calls a day. Right? So you come down to some numbers of what will look like the traffic and based on the usage, right? So we had many different APIs that were being called in different moments depending on the usage. But there is a pattern, right? We came up with a ratio of how many APIs was called in that day, like for each API, how many times it was called, what was the pattern traffic, what was the ratio between each API, and you would use that in the load testing. Like we would reproduce that with the load testing, like call this API B, C, D this many times, this frequency, and that would be testing the system as a whole. And then we would then consider the business growth, right? Like we 100 merchants, oh, it's actually going to be 500, 1,000, I don't know. Like we'll have to keep an eye on that, as it's kind of ideally the system can handle more than it needs to, thinking of this growth. And in the load side, you're pretending to be the client and back to those two goals, right? You want it to be fast and reliable. So we just look at latency, 90% of the response time, 90% of the calls or above for the response time, and in the count of success and errors. And for the tooling, right? Like you might know, these tools are JMeter, Gatling, and Redline 13. So JMeter and Gatling would simulate the load, like we would do parallel calls, not sequentially. And I added here the aspect that the load also needs to be scalable. Like we had issues at some point that we couldn't generate enough load for what we wanted to test. And we had to turn to cloud systems that can generate the load for us and scale, right? So Redline 13 is one example. Because you can set up the test, the JMeter file, and give it to Redline 13. It will spawn instances of in AWS, for example, and it would just trigger the load as much as you want on the cloud, which was really cool and very useful and made testing much easier. But then once we have the load, like what are, given that architecture, what are all the possible tests that you could do, right? I think the first foremost is like the regular traffic. Like, can the system handle the regular usage? Like, oh, this is like, I put here, there's the load test, right? Like, oh, this is what it's going to look like in a regular day. Second test is, will the memory, the application is using memory, and it might not release that memory, and then it causes memory leaks. We had many of those. And we had to do the specific testing for that, right? They usually just use a soak test for that, or like a long run load test. And then you evaluate the memory of the application, and also the garbage collection, if the garbage collection was working properly. The dependencies. So this is what I put the dependency on the architecture diagram, is that once you start testing, depending on the load and how much stress you put, the dependencies might not be able to handle them. that was a big problem for us, and it was especially painful because you might not control the dependency, and you need to work with the owner of that dependency to be able to get to the scale that you need. And of course, find alternatives if needed, remove the dependency, change the dependency, or just scale in a different way if possible. Here, I called it like a stress test, but I want to highlight that for example, if we want to just test the dependency, we would bulk up some of the components in the way so they don't impact the result of the test, right? So it's really stressing where we want the stress to be and not the overall system. We could also do that if we want to. The fourth is the scaling. So I at some point noticed that the scaling logic was not great, and we want it to be, right? We have the scaling setups to work properly. So here I'm proposing is like, okay, simulate that traffic change, like is changing, and is the system falling? Is the system scaling, or will the system fail, right? And you can use the load test for that, right? You using a ramp up or depending on the kind of scaling you want to do. And number 5 here, the disaster recovery. So this was the idea that you have 2 regions, they're both working, they're both handling some traffic. And let's say one region goes completely down. And now the other region is supposed to handle the traffic of both regions, right? So I wrote here the load times 2. Once you're doing the test, it might be that you start with the regular load and then you make it times 2. So it's receiving all that extra load, and will the system handle it? This is an expectation of high availability, right? It's not just performance, but you want to be highly available. You don't want any errors when that happens. The containers in a pod usage ratio. So this was maybe more specific to like Kubernetes and how you can have. It's related to dependencies as well. It's related to how applications grow. You have things connected together that they might respond to stress in a different way. And sometimes you have let's say 10 services, and they are all using one specific dependency, but they might be using that dependency in a different ratio. So here, let me be more clear. This is not an external dependency. I'm thinking of a component inside the Kubernetes pod, sitting together with the application. And so the exercise here was to generate that stress and see, the application is growing, the CPU usage is growing, but the logging sidecar container we are using, it's not growing as fast, or it stabilizes, or something like that. That depending on the container, it might not be a linear growth. And if you have 10 services in Kubernetes, you might give it resources that are the same. Default resources is the danger here, and you want to catch that. Because default resources for one service might work well, for the other might not. And this test would tell you that, like these containers that you are attaching to your main pod, they might need different resources. So this is for capacity planning. And I put here like a stress with a ramp up. So we want to find the growth rate. So you want to, it's like you're stressing, but in a ramp. The 7 is a specific code changes. So this is the usual regression, right? Like we are used to this in unit tests and regular functional tests. But I think that performance needs to be included, that you do a code change, and you have automated tests that would run the performance test. And it's especially critical, like the developer knows, like this specific change will cause, it has the potential to cause performance impact, and needs to be taken more care, right? And this can just be usual load test, but if it's, you would have to evaluate case by case if an extra test is needed, depending on what it's happening there. Deployment rollout, like this was also for the whole Kubernetes high availability. You want to deploy a new version and the system to continue to working well. So you basically test the deployment. You trigger a load and then trigger a deployment and see what happens if there is any impact on the load. Ideally, there's no impact. There could be some issues internally, but from the client perspective, there should be no impact, right? The rollout just happened, a new version introduced, and things just keep working the same as before. This was like for the client side and thinking of what we could do. But then on the server side, once the load is happening, we really want to have a like-for-like comparison, right? First thing I put here is that we want to have a production-like dedicated environment if possible. It's not always possible. Sometimes you have to extrapolate. And you want to eliminate noise with dedicated environment. Eliminate noise can be just that there is no noise, or if there is noise, that noise is consistent. So one test, the noise was there, and then the other test, the noise should also be there. So you can, it's impacting both tests and you can compare, so it's not a problem. We want to consider the warm-up time that might be, and remove that from the test. So basically run the test usually for a longer time. And be statistically significant, again, like it's just collecting more data to have enough. We don't want to, the test should be, there could be some small noise that if you have a longer run test, it could be ignored. Like it's not, you want to see those things. You might want to investigate more why it happened, but in the great scheme of things, it might not be a big deal. Okay, so this was about the load, right? Generate the load, and then what's the feedback look like? How do you absorb that? What's happening? How the system is behaving? And here, to me, is observability. It's critical. Like you can't really at this scale. You either would go only by the client, but that would not really tell you where the issue is. And the observability is essential for finding where the issue is in that. All of those components playing a part on the system, right? So there are many tools available. I list on top here, like for example, the system, the components actually doing the functions. That's where we would instrument for the observability, and they would provide information like Nginx for the access logs, for example, the Kubernetes, Istio, the JVM itself. All of these have the metrics, is generating metrics. And then we need to send those metrics to these observability centralizers, like Splunk, that would be for logs, Micrometer, OpenTelemetry, Prometheus for the metrics, Grafana to do a dashboard, and Zipkin to do traces. There's many of those there. And they, like you couldn't do the work without them, right? Like you can't really evaluate and do the tuning if you can't compare the results which you extract from these. And I highlight as well that you should have some visibility on the dependencies, if possible, or a contact of someone that would help. We can collect the data on every test, like for clear comparison. This, to me, was basically taking screenshots, like, okay, and then you have it side by side and can see the difference. And you have to remember that instrumentation of this also have a performance impact. So this is some kind of noise you could introduce, for example, and you wanna, if you wanna compare something, you wanna add this before and after, right? So we could judge appropriately. And I suggest as well that to use the same as production. Like we had an issue that, well, we instrumented the logs in the test environment in the debug level, and then it was generating so many logs, and it was actually impacting the performance. And when we ran out of space, we had some other issues because it was way too many logs for the load tests, right? Like load test is generating a lot of extra logs. So we want to put it the same as production, and we can maybe throw away the logs after it's written on a file, so it would not impact the performance anymore. But we actually wanted to read those logs, so not always we would throw it away. But we have to consider that and keep that as same as production for a fair comparison. And then we can set up alerts as well. This is useful for if you have like regression testing automation. And of course, production, you would catch things before they get really bad. But that would be the production one. It was more like the SRE team, operations team doing it. And the key metrics here, so this is more the server side. Like all the same metrics that the clients see, we wanted to see also on the server side. It's a different perspective on it. For example, the latency, we can look at the same thing, the response time, 90% of the calls are above the P90. And the expectation is that if the service is taking 100 milliseconds, you know for sure that the visibility of the client will be that 100 milliseconds plus something else, right? The network layer and like the things happening between. For the count of success and errors, we would want to see that the server level, the service level, there could be actually more than what the client sees if there is retries in the picture, right? Sometimes the retry is just to catch that one-off error, and then the client would not see it. Here would get more granularity and understand better what's happening on the server side. And then in the server, once you open the box of the metrics, there's so many metrics. I listed some here that I judged that was very useful, like the CPU usage, memory usage, thread count, the JVM metrics, the garbage collection, and also application specific. We also added our own metrics. So here and there, we would put some metrics that we wanted, that we wanted to look for. And also the dependency health. So this is more tricky because we basically wanted to see if the dependencies are working well. So we would basically go in their logs and look at like, oh, if I'm receiving 100 requests, I expect to call this dependency 100 times if it's one-to-one, and then you go see the dependency if it was really called 100 times, if it responded well, and all of that. And another aspect of it, the feedback loop, and it's more also the thinking of everyone involved, right? Like we wanted to be continuously caring for performance, and we put it in the load testing in the CI/CD, so it is part of their day-to-day, and consider it in project planning and design and new features coming in. Also have like this thought of like, okay, would this impact performance? And there was a constant question that came up, and performance engineer was involved, but the developers drove a lot of that as well. Like the developers could say, oh, this might impact performance. We need to involve performance engineering team. And then also the production team, like they were looking at what happened in production, and they would come and like, hey, this is happening. Is this an issue? Do we need to investigate more? And then you would trigger the performance engineer to evaluate at any point in time as well. And then the results, right? Once we do the tests, how do we deal with those results? I actually put here that it can be boring, like it's like nothing special. That's what I wanted to see. Is like we want to change things, and we just want to see that the performance was not impacted, all is well, move on. But it was also important to just see that, to just understand like what is happening, and getting that confidence that the system is ready for growth. And seeing that, being able to see that there's something that's going to go wrong, and should we act on it or not, and do the prioritization. Right? You have some time, so you can prioritize the issues that are coming, and also avoid some changes. Right? If you know that something could go wrong, or if you do this, that thing is going to be a problem. But if you understand it, you would avoid doing it. And another aspect was just to reproduce a problem as well. So if we had a problem in production, we should reproduce this in development so we can fix. Like the memory leak usually was like that. The memory leak was easy to fix. They would just rotate the servers and the memory leak was gone. But now we need to reproduce the memory leak in develop so we can actually fix it. And we would use the load test for that as well, right? So it's a bit different aspect of using the load test for that. And this is something similar, like what is the result? Like how would you look at results? Like there was the go, no go, right? Oh, there was these changes. Is it impacting performance? What is the issue? Should we continue with the change going forward or not? And we could have something like this, like an API A, B, C. How many requests per second it's doing? What's the response time? Does it match the target? Right, so response time, oh, it's above the target, it's taking too long. Okay, we would fail that test. These are random values, by the way. I just put it there just for an example. And then we would look at it like, okay, what caused this? Would investigate further, basically. And sometimes even if it passed at these metric targets, we would see some other metrics. And then you would try to look at it specifically, like go deeper in the investigation. Yeah, this was pretty much it. These are basically like thoughts on performance engineering and that I like and find interesting. And there was so many considerations, and it was such a rich testing area that I wanted to bring here and bring for discussion. And that's it. Thank you.
Thank you, Keith. That was very good. Very interesting.
Thank you.
Much more involved than any load testing or anything that I've done. I've pretty much been JMeter and throw a bunch of connections and threads at something. So it would be really cool to actually get into the cloud side of things and test spinning up extra nodes and pods and all that. It's very cool.
Yeah. But how would you, for what you did in the past like this, how would you look at the results? Would you like what would be the next steps after you did the test, basically?
Basically, I was using it to see, using like Google Analytics on our website to see what our average, like what's our high number of concurrent users and stuff like that, and try to go a little bit higher than that and make sure that we can handle that kind of load without the website going slow. What kind of odd behaviors it would have for the customer. Okay.
So just on the client side, basically.
Yeah. I mean, this was years ago. This was, before we really, cloud was really taken over for everything.
Yeah. But I guess if you had an issue, you then go to the developer like, hey, we need to improve this or something.
Yeah. In this particular case, it was a third-party vendor that we were integrating. But yeah, we would pass on any issue. Hey, we need to be able to support this many connections, but we actually didn't have any issues, but had we had any problems, we would have.
Okay. So you're basically doing then they probably would have to reproduce that test and then do the analysis on their side, I guess.
It could, or, I would have the logs from JMeter. If we could see specifically where the bottleneck was occurring, then, we could definitely point that out, or at least send them the logs of our test and let them parse through it.
Mm-hmm.
But I just felt like I was only scratching the surface of load testing. And it was a really interesting topic, but it's just like what you were showing, there's just so much to it.
Yeah.
I don't have time. Most of the bigger companies I've been with have full-on separate teams that handle all that. So a lot of my clients I've been with,
that's just not something I've had to deal with. We pass it on to another team that handles all that, or they send somebody to our team. We schedule a testing time and they do everything.
Okay.
How Fifth Third and Kroger are a couple places I've been, and they have their own teams for that stuff.
Oh, interesting. Yeah, we had there was a performance engineering team, but they were not. They were overloaded, and then that's kind of where I got into it. And as I saw all of this, like we were basically, my project was to change the design, and I knew that the design was be like, this is gonna mess up performance. And I'm like, okay, we need to test this, and then they couldn't test it. We didn't have the tests, and I'm like, I'm gonna have to do it myself. And then I just got into it. And a lot of the Kubernetes as well, like the cloud aspect. The Kubernetes, it's such a beast, and it's easy to just get over provision, right? You just put a lot of pods there, and then it's just gonna handle the traffic, but it's not really optimized, right? Like it's not. It could be so much more optimized and like reduce cost and have so many other benefits that if you're doing all this tests that I'm saying here, like you could get to that, right? Like you can start reducing the size with confidence, right? Like you can know that, oh, you can make it small. Is it scaling properly? Then you can actually make small, but don't make it too small, because there's no need. If you always have a baseline traffic that is always going to be there, you don't need to go below that. And all of this thinking, it was like, wow. But yeah, it was like, it took a long time. And especially with the dependencies breaking, we couldn't change things because the dependencies would break. Like we had, like, for example, what was that diagram right here? I can't use the mouse. So it's like all of these services calling the dependency, and each of the replicas, we had to have like so many replicas. Like, let's say each replica could take 100 requests, but we had to have, let's say, 10 replicas taking 10 requests each, because if we had gone above 10 requests, it would break the dependency. The dependency was a bit different. It was actually at the replica layer. And we couldn't increase it. So we had to just replicate a lot. And with the design that I had done, it would automatically increase it. And we had to like fix it. And there was no metrics, there was no observability, like how the instrument, I put a bit of that here, like this modern set of modern Grafana dashboards. We didn't have that in the instrumentation and the observability, like to actually see what's going on. So it was like such a long process to get there, and I don't think we even finished it.
It is a very interesting topic.
Yeah.
Appreciate the overview.